Alright, so the purpose of this video is more for users who are new to Git and who has never used the SSH protocol to communicate with Git, to authenticate, to do their commits into their repos. So what you see here is the Bitbucket website, and typically users notice there are two-way protocols to leverage to get your repos down off of Git. Most beginner users use what's called the HTTPS protocol. It uses the credentials of the users in the URL, passing your user ID, and once you use that, it prompts you for your password, and then you send all your commands through Git. This focus of this video is to focus more not on the HTTPS but more on the SSH protocol, which always leverages the Git user, and it uses this concept of SSH keys, which uses your key pair of the public and private key that you generate to authenticate with. So let's dive in. So this particular repo is just what's called scheduling. But let me show you how you can test to see if you're properly set up to use Git, period. And then we can go into actually pulling down the repos themselves. So let's open up a terminal here. So the first thing I always tell users to do, first of all, make sure you have Git installed. So if you type Git, you should get your basic commonly used commands of Git to come up on your screen. That's the first step. Also you want to make sure that your SSH communication to the Git server authenticates and works correctly. So let's test that out. So always just use SSH. Add a few verb-roses on it. You normally do like 3. The more V's you use, the more detail you'll get an output, so you can figure out what's going on. If you look back on the browser, I'm using Bitbucket, and if you look at the SSH protocol, to access this repo, it starts up with the user git at bitbucket.org. So let's use git at bitbucket.org. Bitbucket is the place where our repo is located. You can do the same thing with if you use GitHub. But in this particular example, we're going to be using Bitbucket. And if you just put this in here, enter, you should get back information where your computer is trying to talk to the server using the SSH. But if you scroll down, you'll notice at the very bottom, this line here says permissions denied. And if you look above it, saying there is no authentication methods that will work. And if you look a little bit higher in your output here, you can tell that it's expecting a certain key to be located in a certain location on your machine. In my case, my user is Stanley, so it's looking in a subdirectory called .ssh, and it's looking for a key called ID RSA. This goes back to the RSA keys that I was telling you about earlier, where you need to generate these keys in order for you to set up your relationship between your key and your ID on the server and your pair to have on your machine to pass back and forth to the server. So let's go back to the site, to our browser, and a really good link you can use if you really don't get how to understand how to do this is if you Google GitHub and SSH Setup. The first link says generating SSH keys. I found this is a very good site to just follow the steps to basically get it, and they'll show you exactly how to generate your keys. But the biggest one to point out is here where it says generate a new key. Every user needs to create this method of authentication, and this method, once again, is basically creating a key pair, a private and public key pair that you now use with or without a passphrase. But this is the preferred method for authenticating to a server using the SSH protocol. You no longer will have to use your password unless you put a passphrase on the pair that you generate. So let's generate a pair here. I'll just copy this command. This command works on Linux and Ubuntu, but I'm just gonna go and just grab this command here. Let's go back to clear our screen here. One thing to note, if you look at my current directory, I'm in home Stanman. If you list out with the LA, it shows all my folders, including my hidden ones. Hidden folders typically start with a dot. So let's go into my subfolder called, let me clear it again. And if you go into my subdirectory .ssh, and if you don't have this directory, go ahead and create it. You can create it with make.ssh. But once you get into the directory, you'll see here that I have some files. Known host is a file that your OS uses to say, hey, this server is okay to talk to. If you ever try to communicate with a host that's not part of your host, your known host, it will prompt you and say, hey, do you want me to add it? And you'll see here I have plenty of hosts in my host file. So, but one thing you do notice, there is no ID pair in my folder. I moved them so we can create one from scratch. So here's the command once again I grabbed from that website. Is basically the command you care about is SSH Keygen, and these just are some parameters. -T is basically to say, hey, what type is RSA? Is it DSA? Just stick with the standard RSA, and then you have a comment you can put in. Typically, it's your email. I'm gonna put my email address on here. And once again, it's the first thing it prompts you with, where would you like to save the file? You see that it's by default it picks up the subdirectory and the name of the file, which is IDRSA. So I typically just leave it where it goes, hit enter. Then it asks you, hey, do you want to enter a passphrase? One thing I'll tell you, passphrases are cool if you really want to be secured. You can generate more than one key pair, by the way. I typically don't like to put a paraphrase on the one that I use to constantly use daily, only because that when you're committing your code, you don't want it to prompt you every time for the phrase. So if you just simply don't put a phrase, then every time you commit code, it'll never prompt you. You just hit get commit, give it a commit message, hit enter, and automatically your commit will go without prompting you for any passphrases, for any passcodes for the server. So that's why it's really cool. Now, to know that it worked, it'll come up with the keys image right here. You get this little message here to let you know. And then if you ls it, of course, if you spit out your directory, you'll see that it created me a RSA file and a public key, which is this is now my pair. It's that simple. So everybody who uses Bitbucket should definitely, on your own machine, generate a pair for you. So this is now yours. If you use multiple machines, it's absolutely fine to take your key pair and put it on multiple machines that you use. But you don't want to do that for machines that several people use. But definitely, to identify yourself to the server, instead of using your Bitbucket or your GitHub username and password, SSH uses these RSA SSH key pair files. So one of them you'll put on the server, and one is like you'll put one on the server. And if you want to look in those files, let's take a look. You have RDRSA. Let's do the public one first. In the public one, you'll see it has some generated stuff in it, which is my key, and then it has the comment I put at the end, which is my email address. And then if you want to look at the private one, is another generated private keys RAS that's identified for just me. Alright, so now we need to take this information and authenticate with the server. So I'm gonna add my pair. Alright, so now let me show you where. The one thing to keep in mind when it comes to your SSH keys, it has nothing to do with your repos. You need to go to your account area. So if you click on your upper right corner and you click on manage account, If you look down the items here, you'll see there is a under security. You have your password, which is what you use for the site itself. But to manage your SSH protocol keys, you click on SSH keys, and as you see here, you can have multiple keys associated to your Bitbucket account. And what you do if you want to add a new key, just click on Add Key. I'm gonna call this SSH Demo, and you literally just paste the information from your key into this box. The good thing about this particular site, which is Bitbucket, there's a command you can use called xclip. You literally can grab this command, this text here, and put it in a terminal, and it'll copy the information from that file, which is IDRSA pub, into your clipboard, and then it'll go into this box. If you don't have xclip installed, you need to install it. Or, so let's, for example, the file it's trying to target is my pub file, which is IDRSA pub. I could just simply cat the pub out, and I could literally highlight it and copy it in. But to the example that's in the website, you could just let me go back and grab it again. You could literally grab it and hit enter. You see here my computer just does not have xclip installed, so to install I'll just put it on. Alright, now you can see that I have the install is finished. So let's try this one more time to clear my screen. Go up to clip, hit go, and now once you give it to your cursor, that means it's in your clipboard, and then I'll just paste it in here, and now we're good to go. So if I hit save, add key, if it's successful, you'll now have an entry for the key added that's associated to my account. And now I'll go in here and retry authenticate to the server. So you go back to your terminal, and if everything worked as planned, we can go back to do SSH www git bitbucket.org, and that's really all you need to test to see if you're good to go. Hit enter, and as you see here, everything went well. And the way you know it worked well is before you saw right above my cursor, you saw it immediately said permission denied. But to know that everything's fine, if you look up in the output, you'll notice right here it says logged in as my username. So if it worked, you should get a message back saying you logged in to the server successfully. And that's when you can start doing, issuing your Git commands to the server. And obviously my shell access disabled, so that's why immediately it closed my connection and I'm back to my terminal. But that's all a good sign that everything worked well. And once everything works well, you then can literally go in here, go to any repo. Let's go to a repo. And once you get to this repo, instead of using the HTTPS, you just go to SSH. You grab the repo information, and then I'll create a directory called repo test. I'll go into my repo test, and now you literally just use your, since we have Git installed, I'm just going to use git clone, and I'll paste in my repo. I'll get on development branch, and now I'll grab my repo. And now as you see here, I have a repo pulled down successfully. So at this point, you can issue any commands you need from to the server using Git. Only certain commands actually talk to the server. Otherwise, you're really just working off your local instance of your repos. And then once you start doing pushes or clones, fetches, that sort of stuff that require communicate to your remote server, that's when it starts using your keys to communicate. You notice that when I pulled it down, it didn't prompt me for any passwords, any passphrases, nothing like that. I can just send commands and everything will work just fine. Also, this particular example I used in Ubuntu. You absolutely can use this in Windows. You can use it in Macs as well.